The last concept from this chapter is looking at the sum to product formulas. And what these formulas allow us to do are to take two different trig functions that are being added and make them one single term that is being multiplied. So for example here, sine of u plus v, we can simplify down to 2 times the sine of this quantity times the cosine of this quantity. So now it's a single term where everything is being multiplied, as opposed to the two terms we had here that were being added. Same thing down here, sine of u minus v, two terms being multiplied, cosine of u plus v going to two terms being multiplied, and cosine of u minus v, same result. So really all we want to do for this section is substitute in and simplify. So for example number 1, finding the exact value of the sine of 195 minus the sine of 105. We might fall into the trap in saying sine of 195 minus the sine of 105 is going to be 90 degrees. However, we cannot subtract values that are inside a function. Just like we couldn't distribute x plus y into a sine function or cosine, we can't just add or subtract signs left and right. So we've got to use our sum to product formulas. And here, u is going to be 195, and then v is going to be 105. So really what I've got here is the sine of u minus the sine of v. Well, looking up here, I can see the sine of u plus the sine of v is that sine of u minus sine of v. This is what I want. So the sine of u minus the sine of v is 2 times the cosine of u plus v over 2 times the sine of u minus v over 2. So I'm going to rewrite these two terms as a single multiplication term, and I'll get the exact value from that. So we know u is 195, v is 105. So 2 times the cosine of 195 plus 105 over 2 times the sine of 195 minus 105 over 2, which is going to give me 2 times the cosine. 195 plus 105 is 300 divided by 2. 300 divided by 2 is 150. Times the sine of 195 minus 105 is 90. 90 divided by 2 is 45. So 2 times the cosine of 150 times the sine of 45. Those values are both on the unit circle. So the cosine of 150, that quantity is negative square root of 3 over 2. And then sine of 45 is square root of 2 over 2. And we'll multiply all those pieces together. Those 2's would cancel. And the negative square root of 3 times square root of 2 is negative square root of 6 over 2. So the exact value of the sine of 195 minus the sine of 105 is negative square root of 6 over 2. And you can see how that's different from sine of 195 minus sine of 105, saying that's 90 degrees, because you know what the sine of 90 is. That's on the unit circle. The second problem on this page is dealing with an equation. And here we want to solve for x. So cosine of 3x plus the cosine of x is equal to 0. Now you might think back to our equation we had earlier that this is a triple angle. However, remember that triple angle formula we came up with was huge. It was ugly. It was cosine cubes minus cosine squareds, all the stuff you'd have to work with. So instead of using one of those formulas, we can see we are adding two different cosines together, which is going to be a sum to product formula setup. So here, my u I'm going to let be 3x, and I'm going to let my v be x. So really, what I've got here is the cosine of u plus the cosine of v. And I can see up there the cosine of u plus the cosine of v is going to be 2 times the cosine of u plus v over 2 times the cosine of u minus v over 2. coming straight from my formula right there, cosine of u plus v. And I know u is 3x and v is x. So 2 times the cosine of 3x plus x over 2, cosine of 3x minus x over 2, plugging in 3x for u and then x for v, which here 2 cosine of 3x plus x is 4x, divided by 2 is 2x. Cosine of 3x minus x is 2x, divided by 2 is just plain old x. So I've got 2 times the cosine of 2x cosine of x. And this right now is all equal to 0. So what I've done so far is I've just simplified this left-hand side into a single term that's being multiplied. So what I've got now is 2 cosine of 2x times the cosine of x is equal to 0. Now I can work with my double angle formula, cosine of 2x, which we've worked with. And since everything is in terms of cosines, let's use the double angle formula that is just cosines. So the cosine of 2x can simplify down to 2 cosine squared of x minus 1, and that's being pulled straight from your double angle formulas, times the cosine of x is equal to 0. And now I can set up all these factors equal to 0. I've got 3 factors being multiplied, set each one equal to 0. So 2 is equal to 0, which is my factor in front. 2 cosine squared of x minus 1 equals 0, and the cosine of x is equal to 0. Now here you know that's not going to do anything for us, but these other two are going to produce solutions. So here with this guy, we'll have cosine squared of x is equal to 1/2. Take the square root to both sides, and we get the cosine of x is equal to plus or minus the square root of 2 over 2. Once we rationalize everything. Over here, the cosine of x is equal to 0. That one's pretty much simplified down. But I don't really have my answers yet. I want to solve for x. So I'm going to come over here and give myself a little bit more room for each of these. So do that. So I've got the cosine of x is equal to plus or minus the square root of 2 over 2, and the cosine of x is equal to 0. Just as we've had in all our other sections, when we get down to this equation part, we take the inverse to both sides. So the cosine inverse of the cosine of x is going to be the cosine inverse of square root of 2 over 2. And we've got to include all the plus or minuses. That looks like a bunch of scribble right there. Let me rewrite that a little nicer. It's the cosine inverse of plus or minus square root of 2 over 2. And then over here, I would do the cosine inverse to both sides. So my cosine and cosine inverse cancels out. Here I'm left with x equals cosine inverse of 0. What two angles give me a cosine of 0? That's going to be pi over 2 and 3 pi over 2. And then over here, cosine inverse of plus or minus square root of 2 over 2. So what are the two solutions that give me a positive square root of 2 over 2? And the two solutions that give me a negative square root of 2 over 2? And those are both on the unit circle, and it's my pi over 4s. So my pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Once again, those are coming directly from the unit circle. If I didn't have something on the unit circle, I'd have to use my calculator, set up my reference triangle, then reflect into the different quadrants where cosines or sines or whatever trig function are either positive or negative.